Hello, so this is lecture number 22, Physics 111, 112. And today I'm going to do some problems. And we start with problem number 18, chapter 20. So problem number 18 states that what current flows through the bulb of a 3-volt flashlight, right? So voltage V is 3 volts, flashlight. When it's hot, resistance is 3.6 ohms. So resistance R is equal to 3.6 ohms. So hot resistance means when the steady current is running, and so all you have to do is just use these values. And what current flows through? So what current flows through, that means you are looking for I. I is equal to how much? And so V is equal to IR. That's Ohm's law, simple formula. So in here, I want I. So I is equal to V divided by R. And V is equal to 3 volts divided by 3.6 ohms. And you put it in your calculator, you will get that I, the current, is equal to 0.83 amperes. Okay? Alright? So it's very simple, just simple substitution. So all the problems today are just simple substitutions. Okay? Now the next one is problem number 19. So you have to look up in the book what the problem is saying, but I'm going to read it out loud for you. Find the resistance of a pocket calculator. So you want to find R, right? Find the resistance of a pocket calculator that has 1.35 volt battery. So V is equal to 1.35 volt. So it's a good habit to read it phrase by phrase and note down what you understand, okay? So pocket calculator that has 1.35 volt battery and through which 2 milliampere flows. So that means current I is equal to 2 milliamperes, right? So by reading the sentence, sometimes they will not say what is what, but 2 milliampere flows, so that you have to understand from the unit is the current. So now you want to find R. So again, you use the same formula. V is equal to IR. But this time, I want to find what R is. R is equal to V by I. And V is 1.35 volts. And I is 2 milliamperes, which is 2 times 10 to the power minus 3 amperes. So that if you put it in your calculator, you will get 0.675 times 10 to the power 3 amperes. Okay? Alright. So now let's do the next one. So the next one that I'm going to do is finding power, problem number 40. So problem number 40 says that what is the power of a 1 times 10 to the power 2 million volt lightning bolt? So you want to know what the power is. the lightning bolt. So lightning bolt, they have a lot of current and a lot of voltage. So voltage here, V is equal to 1 times 10 to the power 2 MV, that is million volts, right? Okay, I'll write it down for you. Million volts. So that means million means 10 to the power 6. So 1 times 10 to the power 2 times 10 to the power 6 volts. That's your V. And the current is 2 times 10 to the power 4 amperes. So let me read the problem again. What is the power of a 1 times 10 to the power 2 million volt lightning having a current of 2 times 10 to the power 4 amps? So current I is equal to 2 times 10 to the power 4 amps. So that's a lot, right? So that's a lot. So 2 times 10 to the power 4, 2 times 10 to the power 2 is 200. So 3 is 2000, 4 is 20,000 amperes, right? So that's a lot of current. So the formula is, remember, let me just derive it for you one more time. Power P is equal to IV, right? Okay. And remember Ohm's law. Ohm's law said that what? V is equal to IR. From here, I can find I is equal to V by R, or R is equal to V by I, right? R is equal to V by I, or V is equal to IR, and then I can also use, alright, so I can use this to get P is equal to I times IR, so I get I square R, that's P. So I'll use this if I know I and R, right? And if I don't know I and R, like in this problem, I just use P is equal to IV. Now I can derive another one. P is equal to, instead of substituting for V, I can substitute for I. So then V by R times V, which is equal to C. Here I is substituted with V by R times V. So that's V squared by R. So I can get P is equal to V squared by R also. That one I will use when I know V and R. Alright? But in this problem, I know P is equal to IV, current is given, and voltage is given, so I'll just use that. So I'll use P is equal to IV. I is 2 times 10 to the power 4 amperes, and voltage is 1 times 10 to the power 2 times 10 to the power 6 volts. So multiply it all together, I get 2, 10 to the power 4 and 10 to the power 2 is 6 times 10 to the power 6, so that's 10 to the power 12. And the unit for power is watts, because everything is converted to ampere and volt. So that's the answer, right? Okay.